Before using a measuring tool, it must be cleaned and checked for correct calibration. A vernier caliper can simply be wiped with your finger or a rag, and to check its calibration you would close it all the way up and check that it reads 0.
Clean a micrometer by closing it on a piece of paper and pulling it off. This will make measurement more accurate.
To check a micrometer's calibration, you measure the length of the calibration rod. It should read the exact amount as printed on the rod. To clean an inside micrometer, you would just use a rag to wipe the ends. Inside micrometers are checked for correct calibration with a tool that comes in the kit. You place the micrometer inside the tool and take the measurement of the jaws. This figure should equal the figure printed on the side of the calibration tool.
Place a straight edge on the block deck. Note, a ruler is not a proper straight edge, it was only used for an example. If a gap is detected, it must be measured with a feeler gauge. Repeat this process in a few spots and record measurements. The sleeve must be clamped down to imitate its position when the cylinder head is bolted onto the block. Do this with bolts and large solid washers. Torque the bolts to the manufacturer's head bolt specifications. Set up the dial gauge, then measure the height difference between the block deck and the cylinder liner.
Bore diameter can be measured with an inside micrometer. Place the micrometer inside the cylinder and take the measurement just below the wear line of the rings. The diameter is read by adding the length of the required adapter pieces to the reading on the gauge.
Cylinder bore ovality and taper can be measured with a cylinder bore gauge. First, the gauge has to be set up with the correct adapters so that the gauge can read both sides of the bore.
When the gauge is put in the cylinder, the needle is pushed back into the tool. Rock the tool back and forth to find the squarest reading. The measurement is the total length of the base of the tool, plus the adapters that were added, minus the reading on the gauge. For ovality, you take a measurement in one spot, then rotate the tool 90 degrees and take another measurement. For taper, you take a measurement at the top of the cylinder and another at the bottom.
Before measuring any of the journals, they should be visually checked for discoloration and scoring. Journal diameter is measured using vernier calipers.
To read a vernier caliper, you look at which millimeter increment on the stationary scale is closest to the 0 on the sliding scale. In this case, it's 27 millimeters. Then see which increment on the sliding scale lines up perfectly. This finishes the measurement with points of a millimeter. This picture shows our total measurement as 27.26 millimeters.
To read a micrometer, you look at which millimeter increment on the main scale is closest to the end of the secondary scale. In this case, it's 45 millimeters. Then see which increment on the secondary scale lines up perfectly with the main scale. The picture shows 0.2 of a millimeter, which makes our total measurement 45.2 millimeters.
Journal ovality is measured with a micrometer by taking a measurement in one spot, then rotating the crankshaft 90 degrees and taking another measurement. Taper is measured by measuring one side of the journal, then measuring the opposite side of the journal. To determine whether a shaft is bent or not, you would use a pair of V-blocks and a dial gauge. Mount the shaft on the V-blocks. The V-blocks have to be under smooth journals to get an accurate reading. Set up the dial gauge on one of the center journals of the shaft, then slowly rotate the shaft by hand. If the shaft is bent, the dial will move up and down with each revolution of the shaft. Record the total travel of the dial. To read a dial gauge, you count full millimeters on the small needle indicator, then points of a millimeter on the large dial. To measure lobe surface of a camshaft, you would use a vernier caliper. This measurement is taken at the narrowest part of the lobe.
Measure the cam lobe extension, then subtract the cam lobe width. This will give you your cam lift.
To measure the inside diameter of a camshaft bushing while it's in the block, you would use a hole gauge. Close the needles on the gauge and tighten the clamp. Place the gauge in the hole, then release the clamp. Hold the gauge square in the hole and retighten the clamp. The measurement is then taken by removing the gauge and using a micrometer to measure the length of the needles.
Piston diameter is measured using a micrometer. Piston ovality is measured by taking one measurement in one spot, rotating the piston 90 degrees and taking another measurement. Piston ring side clearance is measured with a feeler gauge set. Slide a feeler gauge in between the piston ring and the top face of the piston ring groove. Piston ring groove depth is measured by using the depth gauge on a vernier caliper. When installing piston rings, make sure they are the right way up. Most of the time they are marked on their top sides. The ring gap should be roughly 120 degrees apart as shown in the picture. Out of roundness in the big ends can be visually checked by looking for discoloration and scores in the bearing.
Bearing retention is an important quality of a bearing. This refers to the bearing not being the exact fit for its carrier. Free spread is the different angle at which the bearing is moulded. Bearing crush occurs because the bearing is moulded to sit higher than its carrier.
Backlash is the free play between the gears. This is measured with feeler gauge set. End clearance is the difference in height between the gears and the housing. This can be measured with a feeler gauge and a straight edge. Side clearance is the gap between the teeth of the gear and the housing. This can be measured with a feeler gauge.
Face warpage can be visually checked with a straight edge. If a gap is seen, it can be measured with a feeler gauge set. Axial run out of the flywheel is measured with a dial gauge set up on the face while rotating the engine's crankshaft. Record measurements while it's turning. Radial run out is also measured with a dial gauge. Drive lugs should be checked for bending and rounding with a square. Do a second check on the same lug 90 degrees from the first position. An oscilloscope is just a voltmeter, but because that is all it measures, it has many more settings and functions for measuring volts than a standard voltmeter on a multimeter. It also picks up readings quickly, making it good when measuring alternating currents. To read the oscilloscope, you have to take into account the settings of the volts per division and time per division dials. If the dials were set at 0.1 of a volt per division and 5 milliseconds per division, this picture shows a climb and drop of about 0.4 of a volt over a range of about 5 milliseconds.